If you've been to IT security talks before, you've probably seen some topics like this. It's everything that we probably already know, like, Bob using summer 2025 as his passwords, and that's how you took their domain controllers, to, phishing with AI, all these kind of, we know these kind of things, but there's also new threats like, quantum computers, and we have to deal with those with encryption. And it kind of leaves you with the feeling that just everything is shit. Everything sucks. What's the point, right? Maybe we should just drop this whole IT thing and go back to the good old days where, there wasn't any computers to hack and it would have to be like physical sabotage to cause real damage and stuff like that. My name is Martin Londal. I used to be a software engineer. I now work as a senior penetration tester and a team lead for the penetration testing team over at the police IT unit here in Norway. And by the end of this talk, I want you to, instead of leaving like I almost leave in every security talk, which is this, really depressed about how bad everything is, I want you guys to leave hopefully with a little bit of a happy smile, because we're going to talk about what actually makes good security products, what we have seen what we're seeing kind of happening in cybersecurity that we don't really talk about. It's just kind of there, but it makes my job as a hacker really hard and is very annoying. So to do so, we need to kind of agree on what makes like a good cybersecurity product or initiative or a protocol that really has made an impact for cybersecurity. And to get on my list, you can either one, bribe me, I'm very easily bribed, or two, you can follow these 3 points. If you solve a problem, a real problem that actually exists, that's really good. You need to have really good corporate incentive. If you have to fight with the C-suite and you have to have like 9 PowerPoint presentations, 17 meetings about why this is a really good thing to do, there probably isn't as strong as a corporate incentive. It's kind of almost have to be that your managers want you to implement this for them. And lastly, it has to be user-friendly, both for the end user, but also for the people who are implementing it. So let's start with my first one, good old HTTPS. In my opinion, this is the gold standard, and this is kind of what I compare other stuff to when I look at initiatives or protocols, something like that makes an impact. But let me prove that. So does it solve a problem? Well, yeah, because the issue with plain HTTP is, of course, that you want to talk to something on the internet, and you have to pass through some networks. If that's your local Wi-Fi, the Wi-Fi here at NDC, or you have to go through, the major highways on the internet to reach that website. You will send some data, you'll receive some data, so you can upload like a file, you can send sensitive data like your username and password, but also maybe health information, something like that. And you can also retrieve data from that server. You can download like a receipt from a web store. You can also just visit a website, and then you will be downloading all the source code for their front end to your browser. And the issue here, of course, as a lot of people know, is that as soon as that one is compromised, either someone sitting here on the NDC Wi-Fi, or someone on your local Wi-Fi, or if it's a large, threat actor that can sit on the highways of the internet and monitor that traffic, well, then they can see everything you upload, they can compromise all your data, and they can, for example, intercept your file downloads and build in malware into them, essentially making a Trojan horse. You'll run this program, it looks like a PDF, it's actually some form of executable, it will run something in the background while also open the PDF. So you see a PDF, it opens, everything is great, but in the background you were compromised. And they can also do that with the website. Any website you then visit over HTTP will just be compromised. They can inject whatever code they want into that website, they can spoof whatever they want, and they can just steal your credentials, take over your sessions, essentially do whatever they want as soon as you're using just plain HTTP. So HTTPS solved that. All the Wi-Fi hacking tutorials that you see online are kind of obsolete to a certain extent, because they were a lot of time relying on you getting on a Wi-Fi and then sniffing plain text HTTP to hack somebody's browser. There needs to be a good corporate incentive to implement it, and there is. Because unless you want warnings like these popping up on your websites, where you would have to have an insecure mark at the top, you will have to go into advanced to be allowed to proceed, Or in certain cases, you get this one, which doesn't even allow you to visit the website. Unless your managers want that, then you need to use HTTPS. You also won't be indexed by any search engines, so that would leave your sales department really sad. So we have the corporate incentives, we know it solves a real problem, and the last thing is user-friendliness. Is it user-friendly to use HTTPS and to also implement it? And it is, because how do you use HTTPS? You just open a browser, and you browse to all the websites, and they use HTTPS, because again, companies want business. And for a drift perspective, for the people who are actually operating, they will get feedback if something breaks. They will get these warning pop-ups. It's very easy to spot them. It is free to set up, and it's super simple. Next one is SPF, DKIM, and DMARC. Now, for those who doesn't really know mail server security, quick rundown: you will have certain records in your DNS. And what you will say is, well, I have SPF, and SPF is essentially, let's point to my mail servers. These are my mail servers. My mail should come from these IP addresses. If they don't, it's probably not me. You will have DKIM, which are, hey, I have some digital signatures. When I'm sending an email, it should have some digital signatures. If it doesn't, it probably isn't me. And optionally, you can add DMARC, which is, hey, if something breaks here, this is what I want you to do. Now, does this actually solve something? Well, it does solve a real problem, because before you had SPF records and stuff like that, if you look at just how mail protocols work, you can be sitting somewhere, there can be a random person on the internet, and he can just send an email to your company with whatever email address he wants. He can just say, oh, I am your company, I'm the CEO of your company, it will just work. So SPF and DKIM, these will stop these spoofing attacks, which were, a problem. Is there a good corporate incentive? Well, once again, if you don't implement correct, if there's anyone in operations here, they will know the frustration, because if you don't implement correct SPF and DKIMs, your email will get blocked. No one wants to receive email from an insecure mail server. They don't know who they're talking with. They don't know if it actually is a company. It's primed for phishing. So they will just block you. And then once again, you get a really sad sales department, where they will be really sad because they're not getting any customers. And lastly, we have the user-friendliness. Now, in theory, from a user perspective, they just send email and it's supposed to work. But this is kind of the one area where these kind of mail records, they somewhat fail, because if you misconfigure them and they don't work, which is quite common, like you will maybe add a third-party marketing department, but you want them to send from your domain, well, then you have to add their SPF records to yours. And if you forget to do that, or somebody just buys a software to do marketing and they don't talk with operations, then a lot of those emails will just be removed as spam. And there's no feedback there. There rarely is. So your marketing department thinks they're doing great. They're sending out all these things, but they're not getting any live feedback. And this is somewhat of the problem with these records. They're a little bit tricky to use because there isn't that feedback. But outside of that, when they're implemented correctly, again, the user doesn't have to do anything. It just works. And lastly, I want to talk about not just React. I'll use React as my example, but secure frameworks. Frameworks that just implement security for you by default. And again, I'll use React as this example, but there are other frameworks like it. So something like React, does that solve a real problem? Well, one of the biggest problems with front-end web applications is cross-site scripting. Cross-site scripting is a super powerful vulnerability. It is really hard to detect and figure out if you're vulnerable because of how complex browsers and HTML is. HTML is very forgiving. Browsers kind of do it a little bit in their own way, depending on which browser. And it can be very easy to make a mistake and have cross-site scripting on your web application, which essentially allows an attacker to either just hijack whatever. They can do actions on behalf of users, steal cookies or whatever, but also they can chain it with other vulnerabilities to create even more damage. So here, for example, I have this great travel blog here. You can go log in, you can post a comment. We would like to take over the administrator account, so we know that this Jane person probably owns the blog and is going to read comments. So we'll craft something like this. We say, oh, what a really cool blog. And then we're going to just hide a little bit of JavaScript at the bottom there, which essentially just says, go in, whenever a user loads this, go into their browser, grab the cookie, and send it over to, in this case, just localhost, but normally it would be some attacker-controlled server. And Jane, when she looks at the post, she just sees this. It's, oh, what a cool blog post. But in the background, my server has retrieved the cookie, which we can then use to log in. And the great thing is, a lot of time, this also bypasses 2FA, because you have the login session cookie, which has already been approved and is valid with 2FA. So even if she has 2FA, she has super strong passwords, I can bypass all of that just with cross-site scripting. And if you're interested in making money from bug bounties, cross-site scripting is a great vulnerability to get good at, because again, they're so prevalent, they're so hard to discover if you don't know what you're doing. And this is what kind of React comes in to stop, and similar frameworks. There's one way of doing it in React, and that is you can implement cross-site scripting vulnerabilities using this function, dangerously set inner HTML. But this is a kind of workaround. If you use this, it's normally because you have to dump something that React thinks is dangerous, but you have to do it this way. So they have this function for the usability of the developers. And the great thing is, if you're sitting here wondering, does my front end, it's run with React, does it have cross-site scripting? Just search for the code. If you find dangerously insert inner HTML, see if users can drop data into there. If they can, you have a vulnerability, which you should fix. And it's super easy to fix. Use a framework like DOM Purifier, pass all that user data into this function, and it will just clean it up for you, and you're way, way more secure. So something like React solves a real issue. It's just there. Is there a good corporate incentive? The answer is yeah, because your developers want to use React. When I made this talk, I told a developer friend of mine that I was going to talk about React, and he was like, great, because React is so awesome because I don't have to use Angular. And that was his whole thing. And he's like, if he's not allowed to use React, he doesn't want to work on the project. So that is your corporate incentive, that it is a good framework. It just happens to protect against cross-site scripting. But that's not why the developers use it. They use it because it's great. And lastly, is it user-friendly? Yeah. The user on the endpoint gets, good. It's a good framework. It runs fast. It looks pretty. The developers like it. There's good documentation. There's a great community around it. So it's user-friendly for both the people visiting the website and also for the people, actually creating the websites. So what have we learned? Well, stuff is actually getting more and more secure. I would like to do some shout outs to, for example, Course, which ruins all my CSRF vulnerabilities and stuff like that, which is super great. If you want to get on the Hall of Fame, again, bribes, it works. But outside of that, get something that actually solves a real problem, something that impacts a lot of people. Have a good incentive for why this should be implemented, and make sure that it is seamless for the users. That's all for me. Thank you very much.